Cool. So let me just switch back to QGIS. Okay. So that's projection. We're going to start getting closer and closer into my study area. I'm going to look at Shenzhen's housing prices. The first thing I'm going to do, though, is bring in the China boundary layer. So if you go back to the demo files, there's a political ocean China shapefile. Drop that in. So you see it's superimposed. Everything's going great because they have layered on top of each other, which is, makes sense. You can see it now, the representation is a little bit different. It's a line, right? So instead of this blob, you have this polyline. So the political ocean China is polyline type. It's a different type of shapefile because all it's trying to represent is the boundary of China. It's not representing any areas within it. It just wants to know the boundary of it. Okay, so we can visualize that in a similar way. If we double click and go to style, here we can set any properties for the line. We can make it thicker, we can make a different color. Okay, so there it is. So now we brought that in, we can start to look at one fundamental kind of concept in GIS, and that's resolution and scale. Depending on what scale you're working on, you have to find the shapefile which represents that geometry and geography at the right scale. So you can see if we're working with the world, maybe this is pretty detailed, but if we zoom in, we're working on the coast of China, you see they're completely different scales. And different things or different resolutions are important for different reasons. So for instance, if we're working on the world scale, we don't want to use something this detailed for the entire world. That file would be incredibly huge. And because GIS reprojects the geometry every time you zoom in and out or pan, it's going to get extremely slow. Because basically for every single point in that data set, every single line, it has to figure out where it is on the screen relative to where it is on the globe. Okay, so if you're ever having problems with like huge files, that's the issue. You need to kind of pick the right one for the right resolution. So if we zoom in now on the Pearl River Delta, it's down here. The next thing I'm going to do is bring in the real base layer that we're going to use to visualize our data, and that is the PRD water boundary .shapefile. So if we drop that in, it's basically a shape that takes a chunk of the water boundary and add a lot more detail. So this is a detail that may be appropriate for our level of investigation. So if I turn this on and off, you can see that it renders the coastline a lot more detail. It has some of these islands. It also has Hong Kong in it, which China one doesn't. So that's important. Okay. And so that's our kind of scale. So that's really important to find the right kind of base layer, basically. Depending on if we know our map's going to be about this size, we want something that represents it fairly accurately. We don't want to use the world map here. Obviously, it doesn't have enough detail. Okay, so that is the base setup for our map. I'm just going to change some of these settings for the water. Okay, so the next thing I want to do, does everyone understand bringing in layers? I uploaded these and a lot more base layers that you might find useful for this region of the world onto the Dropbox in the class resources. But you can also find these online. The school has the X Drive, which is like a huge collection of JS data that's extremely messy, but you can always look through that in your studio.